Hello, my name is Adib Saikali. I'm a Principal Solutions Engineer with VMware Tanzu. I've been using Spring since 2007, and I've been working on VMware Tanzu technologies since 2014. I'm really excited to be sharing a lot of the really awesome features that are available in the Azure Spring Apps Enterprise service.
Hi, I'm Candice Quates, and I'm an engineering manager at VMware.
We are so glad that you are here today. Thank you for joining us. I'm Arthur at Microsoft. I'm on point for everything developers need to build, migrate, and scale Java apps on Azure. I'm also a Java dev. I started in 1995 with JDK1, and I've been having an amazing time with Java ever since. Today, we're going to talk about Spring Apps, particularly how you can simplify and scale Spring Apps in the cloud. We'll start with a brief introduction. The session is packed with plenty of demos. After each demo, we'll also talk in much detail about what is in the demo. Let's dive straight in. Spring is the most popular framework toolchain among Java developers. 61% use it as their primary or only dev platform. You can see the growth. SpringBoot is obsessively developer first, enabling Spring developers to focus on solving interesting business problems instead of writing and rewriting boilerplate code. The Spring community reflects this with wide adoption and engagement. So kudos to all of you. Spring developers deserve a cloud platform that enables them to deploy and scale applications with minimal effort and maximum impact. Azure and Spring work together brilliantly thanks to an ongoing collaboration between VMware and Microsoft that started in 2016. This strategic partnership began 6.5 years ago, and it is going pretty strong. We have worked extensively on integrations, making Spring easier to run on Azure so you can focus on your applications and not the minute details. Azure Spring Apps is a fully managed service for Spring Boot apps that lets you focus on building and running the apps that run your business without the hassle of managing infrastructure. You can simply deploy your jars or code, and Azure Spring Apps will automatically wire your apps with the Spring Service runtime. Once deployed, you can easily monitor application performance, fix errors, and rapidly improve applications. It's well integrated into Azure ecosystem, and it is ready for the enterprises. The service is jointly developed, operated, and supported by Microsoft and VMware. Azure Spring Apps is built on Kubernetes. So the exciting part is you get the full power of Kubernetes, but you don't have to really worry about learning or managing it. A little more details. The big rectangle is Azure Spring Apps built on Kubernetes. Each service instance has 2 dedicated Kubernetes clusters. They are managed by Azure Spring Apps and fully abstracted away from users. Service runtime with managed Spring Cloud components, app lifecycle, log streaming, and many more service runtime features are managed in the right side Kubernetes cluster. Your apps are running in the left cluster in the diagram. Your apps can interact with any Azure service or external service or on-premises systems. Logs, metrics, and alerts are available through Azure Monitor. You can monitor end-to-end using any tools and platform of your choice. You can secure your apps using Azure Active Directory. You can automate end-to-end using your favorite tools and platforms. You can continue to use development tools that you know and familiar with. IntelliJ, VS Code, Maven, Gradle. You can deploy using tools like IntelliJ and Maven. Net, it's an easy way to get started. You can focus on your business objectives and everything else is taken care for you in the cloud. Do you have to manage anything here? Nope, not at all. You don't have to. Azure Spring Apps has absorbed all the complexities with infrastructure, hosting microservice apps, app lifecycle, managing microservices, blue-green deployments, publishing logs and metrics, and the list just goes on and on. Everything is supported by Microsoft and VMware. Now, as you get started, there are 3 simple steps to get started, just 3. Azure Spring Apps is as simple to spin up as it is powerful, and it follows 3 simple steps. First, create a service instance. Next, create an app within the service. And finally, deploy the application binaries or source to Azure Spring Apps. Azure does all the hard work for you. All you have to do is point it in the right direction. It really is that simple. Now, once your apps are up and running, they can connect with Azure services. We have made it possible to leverage the full power of Azure from your SpringBoot apps, and it gets easier to do so every day. We provide mechanisms to connect and interact with data, messaging, cache, storage, directories, and so much more. In brief, there is something for everyone. If you are a developer, you can build and scale workloads at cloud scale. You can easily apply cloud-friendly patterns such as externalized configuration, service registration and discovery, automating, and monitoring end-to-end. You get the full power of Kubernetes without even touching it. You can create any number of environments, automate testing, and advance to production across the globe. If you are in the IT team, you can operate the service and environments at scale. The service becomes the home for distributed workloads. You can connect with services running on Azure or on-prem or anywhere. Now, as you operate, you do not have to worry about middleware management. They are all taken care of. You get unlimited scale. You can align your team's roles and responsibilities to match your team structure using Azure role-based access control. You can apply policy management, monitor and automate end-to-end. You can also implement chargebacks in line with your company's funding model. If you're an executive, you have the essential to minimize total cost of ownership, high availability, plenty of headroom to grow the workload. You can harden your security posture using Azure Security, and everything is fully supported by Microsoft and VMware. Enterprises are running their mission-critical SpringBoot applications at scale on Azure. With Azure Spring Apps, you get auto-scaling, app management, auto-patching, ease of monitoring, and many more rich platform features. Now you get more with Azure Spring Apps Enterprise. Enterprise is a new tier and it's generally available. Enterprise delivers even more productivity, and you can leverage Spring experts to make your projects even more successful. Tanzu components, they provide new capabilities designed for enterprises running Spring applications at scale. And today we are going to show you some of these features. You can deploy and manage Spring applications and polyglot applications built using Node, Python, Go, and .NET. Now, with the fully managed Spring Cloud Gateway, you can route any requests to apps and address cross-cutting considerations for those apps behind the gateway. Cross-cutting considerations like configuring single sign-on for end users using your preferred identity provider, including Azure Active Directory, or considerations like request rate limiting, and many more features like these. Let's talk about support. Support and expert guidance for Spring projects let you develop and deploy applications faster. Now, this diagram shows you the commercial support. When you're using Azure Spring Apps Enterprise, you are entitled to commercial support for Spring Apps and all the modules that you use as part of your Spring Apps. In this diagram, you see the bars. There are two colors, the light blue and the darker blue. The light blue represents the free security updates and bug fixes that you get from the open source Spring community. Now, when you're using Azure Spring Apps Enterprise, you are entitled to the commercial support. So you get the business support from Spring experts during not only the open source timeline, but also an extended support after the open source as already announced end of life. Right? This will help you so that you get your critical bug fixes, security fixes. This will help you to keep going and at your own pace rather than get on the 6-month support cycle from the open source community. You can monitor your apps end to end using any tool and platform of your choice. You can use application insights, log analytics, New Relic, Dynatrace, App Dynamics, Grafana, Elastic, or Splunk.
To demonstrate the capabilities of Azure Spring Apps Enterprise, let's consider a typical application with a front-end user interface and one or more back-end APIs. Such an application is going to have a certain set of requirements. For example, we're going to need an API gateway to route traffic to the correct components of the application and to enforce cross-cutting concerns such as the user needing to be logged in. We're also going to need an identity provider so that when we want users to log in, we can redirect them to the right place to log in. And then, of course, since we're building multiple backend APIs, we're probably going to need one or more databases to store our business state. And typically, like many enterprise apps, our information security team is going to require us to store our sensitive configuration data like passwords and API keys in a secrets management solution. Once we have those pieces, we're also going to need a way to implement continuous delivery for the application and its components. And so we're going to need a method of automating the deployment of the application, a way of monitoring the application to support troubleshooting, planning capacity, and keeping an eye on production. And finally, we need a runtime that's going to be able to auto-scale the application components based on the number of requests that we're getting. Now we're going to see a demo of an application called Acme Fitness, which is an online store. And this demo is going to show you the capabilities of the Azure Spring Apps Enterprise.
I'm going to use a fitness store application to illustrate some platform features here. To demonstrate that, I'll be ordering a few things. Let's look for a bicycle. Here's one. We'll add it to the cart. Next, I want a water bottle, so let's add that one to the cart too. Hopefully it's insulated. And go to our cart and see all of our items and proceed to the checkout. Add an address. Done. Choose a shipping speed. Sean's tractor. Add a credit card number. And continue to review and hit place order. And it succeeded. Great. Here's the Azure portal where this Azure Spring Apps deployment is running. You can see the Tanzu components on the left side. And here are the apps that make up our fitness store, like the catalog, the front end, and the cart. The repository for this application is hosted on GitHub, and it has detailed instructions to get started. You can do everything I'm showing today by following the instructions in this repository. Now, I also have this open in VS Code. Here's one of the SpringBoot apps, the catalog services controller. I also want to show the front end, which is written in JavaScript. It's a Node app. It runs in Azure Spring Apps too.
So the Acme Fitness application that you just saw is actually a polyglot application. It has components written in Spring Java, a set of APIs. It has and also some components written in Python, and C#.NET. So it's a polyglot application. And then we also leverage Spring Cloud Gateway with a set of commercial filters to enable the routing of traffic to secure the application endpoints. Azure Active Directory is used as our identity provider to manage logins into the application. Postgres is used as our database of choice for the various APIs that exist. And then we're leveraging Azure Key Vault in order to store all of the application's secret. Now, in all of this, in order to deploy it, do the automation and the monitoring, we're actually using Azure Spring Apps Enterprise because that makes those, the automation, monitoring, and scaling super easy.
Let's start from scratch and create an Azure Spring Apps service instance in the portal. As you can see, we already have Enterprise tier selected, and we've chosen a name and a region. The Tanzu components are here, and support for the entire Spring runtime is included. Tanzu Build Service is included by default as well. The rest of the components can be added and configured as needed. Service Registry, App Config Service, Spring Cloud Gateway, and API Portal. When we're done here, we can go to the Review and Create button and see what we've selected to create an instance. Now let's go to the Azure CLI and create an app for our payments. There we go. After this is created, we can deploy a SpringBoot application into this payments app container. So it's deploy command here. And what this is doing is it's uploading our sources and building a jar. Then it's putting the jar in a container and deploying that container into Azure Spring Apps. It's almost there. Building, succeeded, updating deployment, all right. We're also going to create an app to hold our front-end deployment. It's written in JavaScript. In the deploy command, we're going to upload source files. Tanzu Build Service will apply Node.js build packs to build an image in a container and deploy that.
So as you saw in the demo, a Java and JavaScript apps were deployed. However, you didn't see any Docker files used in the deployment process. This is because one of the best features of Azure Spring Apps Enterprise is that it can containerize your application code automatically using the Tanzu Build Service. As a developer, you can focus on writing code without having to spend time to become an expert at application containerization. Now, the Tanzu Build Service is powered by Cloud Native Build Pack. So let's take a moment and learn a bit more about Tanzu Build Service and Cloud Native Build Pack. So when you think about containerizing an application, you probably think about writing a Docker file. Now, Docker files are flexible, allowing you to control every aspect of the container image, including the OS, middleware, and the command to run the application. Now, while Docker file is a nice single point of assembling an application, they become problematic once you scale the usage of Docker files across many applications and many teams in a large enterprise. Let's take a look at the scaling challenges and how we can solve them. Now, imagine that you have 25 dev teams building and maintaining applications. Each team might choose to write their Docker file in a slightly different way. For example, different teams might pick different base OS images or different distributions of the JDK to use. Without standardization across all teams, you'll run into the following problems. Number one, image updates are hard. The only way to update an image is to edit the Docker file that the image is based on and rerun the build. This means that you'll need to know and understand what's in the Docker file, why it is there, to determine if the change is safe to perform or not. If a critical security vulnerability is discovered in a container image, for example, in a library such as OpenSSL or Log4j, where it's urgent to upgrade to a new version, you'll need to track down every single dev team, ask them to modify the Docker file for their application. Then they need to create, in order to do the patch, then they need to run their pipelines to kind of produce new images. There's really no easy way that a central team can press and automatically update all containers across all environments in minutes. Another problem is that security posture is negatively affected. When each team writes their own Docker file, it's easy for each team to accidentally pick an insecure dependency or configure the container image in an insecure way. It'll be hard to track down CVEs where they're located and perform the operations to fix them. Now, another problem is that full stack container audits are hard. If you're in a regulated industry such as banking or sell your solutions to governments, you might have to perform full stack audits of containers that deploy to production. If every time an app team writes their own Docker file, this audit task will become quite hard. Now, you can impose IT governance rules to review these Docker files each time the team edits them or creates them, and try to drive consistency and security best practices across all container images. You could do that. However, these manual review processes are going to slow down the team's development velocity. They're going to introduce delays into the process of going from idea to production. Bottom line is that Docker files are very powerful, but they are too low level for application developers to use. For code that we write, we can leverage something higher level abstraction than what comes with Docker files. Now, that higher level abstraction is Cloud Native Build Packs. And what Cloud Native Build Packs does, it's a specification to turn application code into OCI compliant images. It consists of build packs, which is an object that can scan the source code of an application, determine what type of programming language the code is written in, identify what middleware dependencies the code requires. It then creates an OCI image using all of the best practices for security and containerization. Now, the developer does not need to write a Docker file. They just focus on writing application code. The Cloud Native Build Packs make it easy to go from source code to OCI compliant containers. So this way, via the build packs, you can drive consistency. You can create a mechanism to separate developer concerns from operational maintenance and security. And this whole thing with Cloud Native Build Packs, it builds on years of experience running millions of containerized workloads at scale. Build packs have been in production for many, many years. So Cloud Native Build Pack provide the centralized easy button to automatically and safely upgrade all the container layers below the application code without having to go back to the development team that wrote the code. For example, if you have 1,000 containers running a specific version of the JDK and a JDK vulnerability is discovered, you can patch all 1,000 containers with a single command. This is going to really dramatically improve your security. So Cloud Native Build Packs allow developers to configure them. And for example, you can specify as a developer that you want Java 11 or Java 17, or a specific version of Node that you'd like to use in your application. So it's kind of giving you that balance between what developers want, which is control of how things are built, and what security and operations team want, which is consistency. So there's this contract where admins can patch all the layers below the application automatically without breaking the application. So we need the Cloud Native Build Packs so we can get speed and safety. Now, I just said that Cloud Native Build Packs are a specification, and therefore there must be multiple implementations of this specification. VMware sponsors the development of the Paketo OSS Build Packs. Now, the Paketo Build Packs implement the build pack specification for all popular programming languages, such as Java, .NET, Node, Python. Now, VMware Tanzu creates a set of commercial build packs based on Paketo that have long-term support and meet all of the stringent security and compliance requirements that enable enterprises to meet regulatory constraints. So on Azure Spring Apps Enterprise, you have access to all the VMware Enterprise-ready build packs. Now, that's not enough. So we have build packs, but we need something and somewhere to run the build packs. And so to get the most value out of build packs and the best developer experience, VMware created another open source project called Kpack, which allows you to run build packs inside of a Kubernetes cluster. You can point Kpack at source code or a Java app, like a jar file, and it will produce a container image. Now there is a commercial version of Kpack called VMware Tanzu Build Service. And since Azure Spring Apps Enterprise is powered by AKS, you can launch instances. The minute you launch an instance of Azure Spring Apps Enterprise, you get a fully managed Tanzu Build Service with all the commercial build packs that can take your source code and containerize it with all the best practices with pre-hardened container images. So this way you can meet all of your kind of security requirements. Here's a screenshot of what that looks like on the user interface. Now that we've learned how source code is automatically containerized by Azure Spring Apps Enterprise using the Tanzu build service, let's focus our attention on how Spring Cloud Gateway works to make it easy to route and secure traffic to individual application instances. The core concept in Spring Cloud Gateway is this idea of a route. A route defines how Spring Cloud Gateway will process an incoming HTTP request. Now, each route has three parts. The first part is a predicate, followed by a filter, followed by some service that is going to actually execute the request. Now, the predicate defines the logic test that determines if Spring Cloud Gateway should actually process this incoming request. For example, you could set it to something like if it's an HTTP post to the /API/checkout URL, then you'd like Spring Cloud Gateway to apply some filtering logic to that. The filter is the actual processing logic for performing a request. For example, you might want to require the user to be logged in order to access a particular endpoint, such as /API checkout. The service is the thing that's actually going to implement the business logic that we want this API to perform. And so it is what Spring Cloud Gateway will forward the request to. If you want to visualize all of this, you can take a look at this diagram. In this diagram, what you see is the flow of how Spring Cloud Gateway works. So first, you have a client that makes a request to the gateway. Then when it arrives at the gateway, it's going to be evaluated against all of the predicates that the gateway is configured with. Based on which predicate matches, it's going to send that request through a pre-request filter chain, and where you can apply multiple pieces of logic. Notice on the diagram that the last filter in the pre-request filter is the proxy one. This is the one that actually calls out to the proxied service, where the actual implementation of the API is located. Now, once the proxied service returns a response, it can be post-processed using the post-request filter chain and sent back to the user. So this way, with this architecture, you have the ability to define any number of filters and combine them in any way that makes sense for your application. So let's take a look at what some of those predicates are and what some of the filters are that ship with Spring Cloud Gateway. So in terms of the predicates, there's a very, very flexible configuration set of options that you can use. High level, you can think of it as anything in the HTTP request headers, such as cookies, HTTP method, query parameters, host name, or even like timestamps, time of day when a particular request was made. All of this can be used to configure whether a particular HTTP request should be processed with a particular set of filters. Now, in terms of filters, there is quite a few of those filters. You have filters that can add, remove, modify headers, map values from one value to another, add and remove security headers. You can rewrite the path, extract segments, add and remove prefixes from URLs. You can redirect users to things like an SSO server. You can perform retries and circuit breaking. You can change the HTTP response code. You can apply a list of roles and scopes, OpenID Connect scopes, that ought to be enforced against a certain set of requests that match the predicates. So in short, you have an incredibly flexible collection of filters that you can use, and the online documentation is quite extensive in documenting what all those filters are that you can leverage. So here's an example of how you configure it. Typically what you do with Azure Spring Apps is that you're going to write a JSON file, and that JSON file is going to define how the Spring Cloud Gateway is going to be applied to the HTTP requests that are being served out from applications that you've deployed to Azure Spring Apps. So if you look at this example here, lines 3 through line 6 are an example of how you define a predicate. In this case, we're saying we're looking for requests that start with /products and that are HTTP GET methods. The filters section, line 7 through 9, is going to define what processing logic we want to apply. In this case, we're saying we want to do two things. One is we want to strip the prefix 0. So we want to remove the first element of the URL. And then we're going to apply a rate limit of 2 requests every 5 seconds. Again, if you consult with the online documentation, you're going to find all the details of how to configure the Spring Cloud Gateway. So let's now see a demo of Spring Cloud Gateway in action.
We're also going to configure Spring Cloud Gateway to route traffic to the front-end app we've just deployed so we can see everything. Let's open the Azure portal for our apps. Over here, we should be able to see 6 services running. Yep, there we go. And we can take a look at Spring Cloud Gateway's routing rules. You see the cart here, and if we scroll down a little bit, we'll be able to see the rules for the catalog. And we'll go to the main gateway page and jump into our application just to show that it's all running. There we go. Here's our stuff. This is API Portal, and it's showing all the routes that are set up in our instance of Spring Cloud Gateway. Here's the cart and the catalog, for example, the route for the front end, which just goes everything, SSO and the users. Let's choose the catalog to show how to test an endpoint. Let's click Products and hit Try It Out, and then Execute here. Let's scroll down, the request succeeded. And if we scroll down a little more, we can see the server response. And we got a yoga mat here that can make you an instant professional with barely any work. Awesome.
As you saw in the demo, it's very easy to configure a highly available and scalable API gateway on Azure Spring Apps Enterprise. Now, Spring Cloud Gateway is the technology that we're using, and it is open source, and it does ship with a lot of filters. However, the Spring Cloud Gateway that is part of Azure Spring Apps Enterprise includes commercial filters that are not part of the open source release. So let's take a quick look at what some of those filters are that implement these commercial enterprise features. So one of those filters is obviously the rate limiting filter, and it takes care of remembering regardless of how many instances of the API gateway you have, it's able to accurately track how many requests have been processed. There's a circuit breaking filter. There's a variety of security filters. For example, single sign-on to determine whether a particular endpoint requires you to be logged in or not, which specific OpenID Connect scopes you need in order to access that endpoint. Further, role-based access control that you can apply to those endpoints. There's also a token relay security filter, which you're going to see a demo of shortly, and various other security filters. So I highly encourage you to check out the commercial route filters. If you've only looked at the open source documentation for Spring Cloud Gateway, you might miss out on some of these commercial filters that are available.
We are going to talk about how to enable single sign-on for this line of business application. Now, when the request arrives at the Spring Cloud Gateway, we'll check if the calling user is authenticated or not. If not authenticated, we'll direct the call to the Azure Active Directory, which will authenticate the user and issue a JOT or identity token. Now, upon successful authentication, the request is directed to the requested API, and the managed Spring Cloud Gateway relays the JOT token to the backend API controller. Let's see how to do this.
We have an app registration in Azure Active Directory to allow us to sign into our app to place orders. We've configured redirect URIs for Spring Cloud Gateway and API Portal that are running on our Azure Spring Apps service instance. Let's configure single sign-on for the apps that make up our fitness store. For that, we'll update Spring Cloud Gateway with the values from our app registration. And then we'll add a route config for the identity service to secure the login endpoint. We can see and edit the SSO configuration in the portal as well. And then we can go to our landing page to jump to the fitness store to make sure it's all still working. Let's log in. Login button. Since we're already logged into Azure, it's seamless. And we can click the login button again when everything comes back up, and you can see my name logged in.
Single sign-on with Active Directory is a check. We just completed this. So how did this happen? We did not write any code. We simply configured. We provisioned and configured an app at the Azure Active Directory and configured single sign-on in the Spring Cloud Gateway. We enabled single sign-on and turned on security token relay. By enabling token relay, Spring Cloud Gateway passes currently authenticated user's identity token to the app when the user accesses the application's route. Now, behind the scene, when we configured, we use the single sign-on authorized endpoint security filter. When the filter is in action, it forces clients to be authenticated before accessing a route. If the client is not authenticated, they will receive a 302 HTTP response with redirect to the gateway's configured single sign-on login page. In this case, it is the Azure Active Directory. You can see the configuration on the right-hand side, particularly line 19 and 20 in the JSON view. Of course, you can configure single sign-on using your preferred identity provider of your choice. We just use Azure Active Directory as an example to illustrate. On the screen, we have two examples of the backend application. Every application has properties that connect to its environment and supporting services. Things like databases, logging, monitoring tools, messaging platforms, and many other things. Now, each requires a way to locate and access it, often in the form of URL, names, and passwords. And if these are exposed, that critical information can be used to access key customer data, even if this data weren't protected by law. And it is in nearly all parts of the globe for all good reasons. Protecting customer data from leakage should still be of utmost importance to all of us. Since applications need that information to operate, the first step app developers usually take is to just embed it within the application itself. This is a huge security risk for many reasons, not the least of which is that it is nearly inevitable, that it'll eventually slip through and be committed to a code repository, then it becomes discoverable. Now, to increase application scalability, app developers typically move on to externalizing key data values and credentials so that multiple instances of the same application can load the same values, dynamically refreshing when they are updated, also loading it in different environments where there'll be different credentials. This only shifts the risk from the code to the execution environment. You can see it on the top portion of the application where you see an example of the service that uses environment variables for key credentials. Now, you can use Azure Key Vault. Azure Key Vault provides a better, safer, and much more secure way to manage secrets. With Azure Key Vault, you control storage and distribution of application secrets to reduce accidental leakage. Applications can securely load these credentials. Now, Key Vault uses role-based access control to lock down access to only those requiring access. You can grant them to admins of course, but also the applications, right? Using the principle of least privilege. Now, apps need to authenticate. They need to be authenticated or authorized using Azure Active Directory and role-based access control. And of course, you can monitor the access and use of secrets in Key Vault with a full audit trail. This way, you can securely load these secrets.
We have a Key Vault to hold all of our fitness store application secrets. All of the app secrets are here, such as database information that the apps need to know, credentials and connection strings, information monitoring credentials and SSO URIs. For all our apps, we've granted access to read these secrets directly from Key Vault, where no one else can see them. Let's tell the catalog service to load secrets directly from Key Vault. That's all it takes. We can now open the portal and go to the store and see all the items in the catalog retrieved from that database. We've configured the apps to load secrets from Key Vault, where only the apps can load secrets directly into memory with no code changes or recompiling needed. Only the apps can see secrets, no one else can. This is zero trust in action. Right now, everything is up and running, but when something isn't working as developers, we need logs. This query shows error logs and exceptions for all our running apps that make up the fitness store. We can refine that by lots of different criteria. For example, here are all the logs for the catalog service. We can look at logs for the service components as well. Let's look at the Spring Cloud Gateway logs. This is where we can debug our route configurations, and we can see that I need to look at an exception later. If our apps are having trouble communicating with each other, we can troubleshoot app registrations in the logs for Service Registry. There are many more options to build queries, and it's easy to do. Just tab complete your way through the query builder. Now, if you're an engineer like me, you also don't want to go to a portal to see logs all the time. You want to tail logs from the command line for your running apps. You can do that like this in the AZ CLI. And here are our logs. Let's look deeper into our fitness store application with Application Insights. By looking at the application map, you get a 10,000-foot view of all the components and their dependencies. Let's take a closer look. This is the identity service, the order service, and the payment service. You can scroll down a little to see our catalog service over here. There it is. And back up to see the cart. There. Now for our components. This is Active Directory. You can see the login URL on the side. Here's our Key Vault, where you see the calls for secrets. Scroll down to find Service Registry. It's right here. And we can take a look at Postgres. Let's go into Postgres to see how our queries perform. Here are all the calls that translate into SQL calls. And the individual queries are right here. Before we get into those individual queries, let's look at all the calls in the application. Let's click on the product call to query the catalog. Here it is. And we can drill into Postgres. And by clicking over here, we can see the exact SQL query for products that originates from Spring Data JPA. That's super cool. We can also see the exceptions, and you can drill into those to see stack traces just like we saw in the logs. As requests are coming in, we can watch them with live metrics which have less than 1 second latency. Here are all the calls going in, and all the servers powering the fitness store over here. We just monitored our apps and dependencies from end to end, all of this without writing any Java code. All these cool charts come by default. We used Application Insights, Log Analytics, and Azure Monitor, but you can also turn them off if you want. You can monitor end to end using entity monitoring tools and platforms of your choice, such as New Relic, Dynatrace, AppDynamics, Elastic, or Splunk. Let's go further and automate our work with GitHub Actions so that we do not need to build and deploy apps by hand. Here you can see a provisioning workflow, and we've set up a workflow for each of our apps in our fitness store and a cleanup workflow to deprovision all the things. Let's zoom into the provisioning workflow. We're provisioning everything with Terraform here, and we can see all the steps involved, such as setting up Terraform, creating up an instance, setting up the extension. Scroll down a little bit to see all the different components being configured, such as app config service and Tanzu build service. Let's take a closer look at configuring Spring Cloud Gateway. Let's scroll down a little bit to get to it. Here it is. So if I click into that, we can see what's it doing. It's assigning an endpoint so that we can reach our Spring Cloud Gateway from the outside world and see our application. Now that provisioning is done, let's look at deploying the catalog application. We can see the build succeeded, so let's look at the steps. Here's the setup of JDK 11 over here. And we can look at the setup of, say, the Azure Spring extension right here. Nice and simple. And here are the deployment logs over here. As we scroll down, we can see Tanzu build service starting up here. Scroll down and start seeing our build packs being applied. And in a moment, we'll see Gradle. Now, all these things the logs are all right next to the source in GitHub, so you can find them when you need them. They're linked to the commit they're based on.
As you saw, you can build end-to-end automation from idea to production using a wide range of automation tools and platforms. Now, typically, we see our customers create pipelines that are broadly classified into 3 categories. Provisioning pipelines. You can provision Azure resources using Terraform, ARM templates, Bicep templates, or Azure CLI. This way, you can create repeatable scripts to spin up or spin down environments consistently. You can use build pipelines that support your favorite build tools. Use Maven or Gradle to build and store jars. Deployment pipelines that use GitHub Actions, Azure pipelines, or CLI. You can use blue-green deployments. Blue-green deployments are very popular, and they allow you to keep critical systems in production while deploying updated applications and transitioning seamlessly between them. So we just secured secrets using Azure Key Vault, and we monitored app instances and the entire workload using Application Insights and Azure Monitor. You can monitor using any tool and platform of your choice, say Application Insights, Log Analytics, Dynatrace, App Dynamics, New Relic, Splunk, or Elastic. Also, we automated end-to-end from idea to production.
So Spring Cloud applications typically externalize their configuration into Git repositories and access those configurations by running a config server that pulls the settings from the config repo, from the Git repo, and then you make REST calls to the config server in order to retrieve specific settings. And this requires you to add a client library to your class path in order to make this work. In Azure Spring Apps Enterprise, there's a new capability called the Application Configuration Service. What this capability does, it makes it so that you have a more polyglot-friendly way of pulling your configuration settings. The way it works is that you can see in the command below, you issue the command to say, hey, Azure Spring Enterprise, can you go and look at the particular URI where my Git repository is located? And then you pass a pattern, which is a set of files that you wanted to pull. Then those are then turned into config maps and given to individual applications as needed. This way, you don't need to include the client library for Spring Cloud Config Server in your application. And if you have a polyglot application, you might have a Python service, you can more easily get at the configuration settings.
Today, we made a full trip. We took a common business application workload and deployed to the cloud. You can do it too. Of course, everything is available on GitHub. You can deploy, effortlessly route requests, set request rate limits, configure single sign-on, connect app to database, securely load app secrets, monitor end-to-end, and automate from idea to production. Azure Spring Apps has 3 tiers: Basic, Standard, and Enterprise. Enterprise is the new tier, and it is generally available. Enterprise delivers even more productivity, and you can leverage Spring experts to make your projects even more successful. Now, the Tanzu components, they provide new capabilities designed for enterprises running Spring applications at scale. Today, we showed you some of these features that you see on the screen. Now, you also get support. So support and expert guidance for Spring projects let you develop and deploy applications faster. As you use Azure Spring Apps Enterprise, you are entitled to commercial support for Spring projects. Everyone watching today can build cloud solutions and advance them to production. We love to hear how you are building impactful solutions using Azure Spring Apps. You can get started today. You can deploy your first SpringBoot app today. You can also use a self-paced workshop to learn the details of the service. If you prefer videos, we have great YouTube videos. Follow the Spring playlist. You can also leverage best practices for deploying SpringBoot applications. You should let us know how you are building impactful solutions. As you start using Enterprise, you can ship faster and unlock Spring's full potential. On behalf of Adeep, Candice, and myself, thank you for joining us today. We are available here to answer all your questions. Please share your questions in the chat window, and thank you again.